Okay, so back to our projectile and vector reviews. On problem number 8, we are talking about Wile E. Coyote dropping a bowling ball from the top of a cliff trying to catch that roadrunner. The cliff is 132 meters high. So again, we draw our picture. That's 132 meters. And he's dropping a bowling ball. So how long does it take for the ball to fall to the ground? So again, we're looking at our motion in the y direction, and so we use our equation that says y equals 1/2 acceleration in the y direction times time. And that'll tell us how long it takes. We substitute in 132 meters, and we're going to divide that by 1/2 the acceleration of gravity. And that will equal the time. And we plug those in, and we find out that time is equal to 5.2 seconds. The next question says, what is the impact velocity? So we want to know the velocity of the boulder in the y direction. So we look at our equation here, and it says velocity in the y direction equals the acceleration of gravity times time. So we plug in what we know. We, of course, know the acceleration of gravity is 9.8 meters per second squared, and we found the time to be 5.2 seconds. And so we can find the velocity in the y direction will be 51 meters per second. And the equation tells us it's negative. Negative just means, of course, that it's going down. So you can write either negative or the direction that it is accelerating. So part C says, how far does it fall in the first 3 seconds? So we can go back again to our equation, and of course I'm just seeing up here that I did that incorrectly. That should be squared. Still gets the same answer, but t squared is 29. Whatever. So we go back up to our equation that we used initially, that y equals 1/2 acceleration in the y direction times time squared, and we plug in a new time here to find out a new y. So 1/2 9.81 meters per second squared times the new time squared. So that was 3 seconds. Squared is 9 seconds squared. And we solve for y, and we find that it is 44.1 meters that it fell in the first 3 seconds. And the next part of the question says, how long will it take the same ball to fall if the cliff was on the moon? So the only thing that's going to change in that part of it is going to be our acceleration. We'll no longer use 9.81 meters per second squared. We'll use the force of gravity on the moon, which is 1.63 meters per second squared. So we would solve just like we did in part A, only we would use the acceleration of gravity on the moon in place of that. And that turns out to be 12.7 seconds that it would fall if it fell on the moon versus the 5.2 that it fell on the Earth. And the last part of this question says, if a roadrunner is approaching the bottom of the cliff at a constant speed of 65 kilometers per hour, how far away would he have to be when Wile E. Coyote drops the boulder for it to actually hit the roadrunner? So how do we do this? We know that he is going at a constant speed of 65 kilometers per hour, and we know that our velocity is going to be in meters per second. So we want to convert that to meters per second. How do we do that? We convert kilometers per hour to meters per hour, and we just multiply that by 1,000, and that would be meters per hour. And then if we want to convert it to meters per second, we know that there are 60 minutes in an hour and 60 seconds in every minute. And so we would divide this number by that, and we would end up with 18 meters per second that the Roadrunner is approaching the cliff. So then we know that the velocity equals the distance divided by time from way back in our first chapter. So we know if the Roadrunner is approaching with 18 meters per second velocity, we want to know what distance will he cover in the amount of time it takes for the boulder to drop, and we've calculated that in A as 5.2 seconds. So we then multiply 18.5.2 and we end up with 93.6 meters. So when the Roadrunner is 93.6 meters away, if Wile E. Coyote drops the boulder, he will hit the Roadrunner. But we know that that never happens, and he probably drops the boulder on his own head. The last problem we have is a baseball question. It says a pop fly ball is hit by Tommy Sosa, and the fans time the flight of the ball at 6.7 seconds. So the question asks, how high did the ball get? So now we know that we're going to use our non-horizontal equations. How high did the ball get? We need to figure out the velocity of the ball. And so we can look at our equation for the time total, which we could also have the time total is going to be 2 times the time at peak. So we know that time total is also going to equal 2 times the velocity in the y direction divided by the acceleration in the y direction. And so we know that we had the total time given to us in the problem, 6.7 seconds. And we know the acceleration of gravity, so we can move that over to this side of the equation. So times 9.8 meters per second squared. And that will equal 2 times the velocity in the y direction. So solving for velocity in the y direction, we find that it is 32.83 meters per second. Once we have the velocity in the y direction, we can calculate the height. And so we solve height equals velocity in the y direction squared divided by twice the acceleration in the y direction. So plugging those in, we get 32.8 meters per second squared divided by 2 times 9.81 meters per second squared. And we find out that the height was 54.9 meters in the air. And so hopefully that will help you get through all the vector and projectile questions and worksheet number 6.